A warm welcome. This is Electric Energy Generation, Utilization and Conservation course with lecture 5.2 focusing on induction-based appliances. Induction normally refers to the electromagnetic induction principle, and let us see how the appliances are operating based on this principle. So the induction appliances, they get energy from the mains voltage, which is then rectified by a bridge of diodes. Here let us see this circuit. This is a power electronic circuit of an induction cooker. So first we'll have the mains. It may be of either 50 hertz or 60 hertz. In the Indian system it is 50 hertz. We are applying the voltage, and this voltage, AC voltage, is first converted to DC with the help of a rectifier in connection with this filter circuit. This DC voltage is then inverted. It is then converted to AC again, so that it will be completely making the system into a the system should be brought under resonance condition. So at that condition, the system has to be utilized for the particular application. For that purpose, we are using a resonant inverter here, and then we are converting it to an AC supply and is then applied to the load. So now we can see here, this is the sinusoidal AC voltage which we are applying, the voltage and the current. It is then further converted into DC. Since we are using a full bridge rectifier, we have a full bridge full wave. Next, upon application to the resonant inverter, we can see how the inversion principle has been completed with the necessary arrangements of the pulse width modulation techniques. Here, thus the frequency is getting converted to 20 to 100 kilohertz rather than 50 to 60 hertz. So hence, when frequency is improved, this application over the usage of the induction cooker will effectively provide a heating which will be a uniform one as well as intense one. Here the bus filter is designed to allow high voltage ripple and thus getting an input resultant input factor close to 1. So the power, if it is power factor is 1 to equal to 1 means then it is a satisfactory 1. So for the electricity board also, then the inverter topology is, this is the thing, it will be generating the or it will be converting the input signal to the a comfortable signal for the induction process to occur. So today, burners of domestic induction appliances are designed to deliver up to 3.5 kilowatt. And while considering the resonant inverter, we are going to see two different types of resonant inverters. One is a full bridge and the other one is a half bridge. A simple circuit, here we have taken an resonant inverter. We have taken the inverter circuit and we have connected the RL load, and then in connection with that we have connected one more IGBT. That is the case in the positive as well as the negative mode. We have connected two IGBTs. This is a full bridge rectifier. So we can have a control over the resonant inverter based upon the switching operation of all these 6 IGBTs. In case of half bridge, it is nothing but a capacitor. So in half bridge, it purely depends upon the charging and discharging effect of the capacitor, and this is what is the difference between half bridge and full bridge. So under full bridge resonant inverter, we'll have a complete control over the switching operations rather than half bridge. But in certain cases, in order to reduce the cost or economic for economic operation, the switches may be removed and capacitors may be placed instead. While considering the induction cooker, it purely works on the principle of electromagnetic induction. Special cooker is also needed for this purpose. The cooker used is an induction cooktop. It must have an iron content because for the generation or yes, electromagnetism has to be generated, right? So electromagnetic energy plus the magnetic pans will fasten the process of induction heating, and thus efficiency will be getting improved. Actually, first it operates beneath the ceramic surface of an induction cooking product. That is, there is a copper coil. when an electric current is passed through this coil, it will be creating an electromagnetic field. We know that. And this iron core pan which is placed on the cooktop, the heat is activated around the pan due to the generation of electromagnetic flux. That is, when flux is produced, automatically heat will be generated and this heat will be activated around the pan. Thus, the surface remains cool until both these steps get completed. When the magnetic pan is placed on the cooking surface, the iron molecules in the pan begin to vibrate. That is 20,000 to 50,000 times per second. This will be a friction state, and this friction state between the molecules will be creating the heat. All the heat will be contained in the bottom of the pan, and thus the surface remains cool while your cookware stays hot. This is the condition.